Genome sequencing has the potential to usher in a new era of medicine. Some predict that within a few years, a patient's unique genome sequence will become a routine part of his or her medical record, like cholesterol levels and blood pressure readings. For now, genetic testing is mainly used to determine the cause of an existing medical condition or to gauge the risk for other family members to develop a known genetic disease. Consider the Lennon family. The Lennons' first child, Addison, was born with microcephaly, in which the brain fails to achieve its normal size. When their fourth child, Brooks, was also born with the condition, doctors suspected that their disease had a genetic basis.
Researchers here at Children's found mutations in the DNA of Addison and Brooks in a new gene important in brain development. While we were working out our findings, the family let us know they were expecting again. Luckily, we were able to test the DNA of the unborn baby and found it did not contain the same mutations, indicating the baby would not have the same condition.
Today, whole genome sequencing means healthy individuals can also learn whether they're at increased risk for certain diseases, and sometimes how they might alter their lifestyle to reduce the risk. Additionally, research is revealing how to use genetic data to treat patients more effectively. These advances provide amazing opportunities, but at the same time raise questions that leave some wondering whether we're moving too quickly before important issues are adequately addressed.
How can we protect the privacy of individuals who have consented to be tested? How do we ensure that the genetic information we receive is accurate? And who will have access to that genetic information?
We can only imagine the promise the next 10 years hold for genomic research, but many agree we need to proceed thoughtfully so that as we fulfill this promise, we do no harm.
Good afternoon, everyone. I am Paul Billings, and the topic of our panel this afternoon is the $1,000 sequence, now what? And I actually thought that little clip that we just watched does set up many of the issues of what is behind the now what question. What kinds of technologies are we going to use, to what end, and what other issues are we going to turn over as we begin to apply that. So I'm going to pose this question to you, Chris. When someone asks you about the specific benefits of the $1,000 sequence, what do you say? What do you say about it?
The costs are not obviously more expensive than doing a systematic and thorough genetic evaluation using existing technology. But furthermore, the likelihood of finding something that can actually change management is substantially greater, actually, because we're actually finding out more about the diversity of disease. We find that there are mild forms of conditions or unexpected presentations of known conditions, which are occasionally very treatable.
Are you also going to see the growth of targeted treatments to specific genetic mutations?
This is one of the most exciting things really going on in the hospital now, is actually trials at our hospital in the developmental medicine clinic and also in the neurology department for specific targeted therapies for particular pathways that have been implicated, particularly in some of these childhood neurological conditions like intellectual disability.
Really, the basis of this panel is the dropping cost of genomic analysis as a component of both the developmental cost and the commercialization cost. Comment on that.
Oh, in our study, our 600-patient study, the cost of whole exome sequencing, I think, is about 20% or so of the overall cost of per child. From a clinical trials perspective, it's no different than any other work you do in the laboratory. With regard to work that you do in the laboratory, one of the things that has astonished us, and Patrice, in the wake of the comments you made on the video, is that in order to be enrolled in our study, the family has to agree to donate. The child donates RNA, but not necessarily DNA. And we were quite concerned that few families would consent. Over 80%, about 85% of families are consenting. The last frontier that remains, in my mind, is how do you communicate complicated information to parents and to primary care physicians? This is done today at a retail level by genetic counselors, enormously skilled and committed individuals, but this doesn't scale as we think of every one of us having our genome tested, or every one of our children as they're born having their genomes tested. So one of the great challenges for us and the great opportunities is rethinking reports.
Our challenge now is to really achieve this new vision of the next generation, which is truly you can go into the laboratory and in the afternoon run a chip, and 5 hours later have your exome sequenced. So that poses a whole new challenge of the interpretation of then that variant information. And Stan and I were talking about this at lunchtime. We can do it at a genome or an exome level on a select group of individuals. But when you think about what we really aim to achieve, it's 6,000 individuals or at scale. So that really is something that we need to be thinking about collectively as a community. And I think, again, Claritas with a vision that it's not just BCH that will be supporting, but it is the pediatric hospital community network that we will create that will then foster the knowledge of that information, how you interpret that, and then how you report it.
You're all interested in, it seems to me, in one way or another, in neurodevelopment, autism, developmental disorders. What should we expect in the next few years?
I think we can expect a large number of these kids, and again, you probably all know them. Neighbors' kids or kids down the street who have some sort of disability, and the parents will say, well, we're not exactly sure, what it is. The reality is we should know what those are. We have the technology to diagnose at least the 25 or 30% of those kids that now are mysteries. Life is not going to be changed for the vast majority of kids overnight by having their exome sequenced, but there will be some kids who will have their life impacted very quickly by having an exome sequence. That might be 1%, it might be 5%, it might be 0.1%. I can't tell you what that number is, but we ought to know what that number is.
If there's one thing that genomics has given us already, at least for disorders like autism, schizophrenia, is that disorders of the mind are disorders of the brain. That paradigm is revolutionary. As recently as 20 years ago, autism was thought of entirely as a behavioral disorder. That is, bad behavior, remote behavior of a child was due to bad parenting, external stimuli. The fact that it has its roots in biology is everything. I think we'll continue down that path, and that the power of genomic technologies will accelerate it enormously. The evidence is already in place that it has.
There are more than, I think, 3,600 diseases which you can catalog based on a mutation that exists. And the ability to apply that to the very sick children that you see that really are the extreme phenotype and where you see that disease most evident is really the foundation for what Claritas aims to bring clarity to, so that we can help a global community really understand with the tools that exist today that at scale and in cost can make that information available, but then also the interpretation of that, which is the power of more knowledge than just one individual. And again, whether it be a whole genome, a whole exome, or gene panels, as we do today, that those will become just an integral part of a medical record that we really can use for improving healthcare.
Ultimately, we always know that information is going to lead to better outcomes, and so the challenges will be to how to navigate that process of the utilization of information and manage it.
We haven't directly addressed a couple of the issues that Patrice raised in that little video clip, right? She talked about privacy. She talked about discriminatory uses, or things that, and other kinds of policy challenges and environmental challenges, community challenges, which could potentially retard the number of people who take advantage of this, slow its application?
I had my sequence done by George Church. My sequence is on the web for all to see. That gave me not a moment's pause, but as an occasional director and officer of public companies, I hate it when my compensation is a matter of public record. So I think if each of us ranks things that we'd like to be private, that not always are. Certainly the genome ranks below that. There are other behaviors and mores that we each have that we'd rather perhaps keep private, or at least not comport ourselves in public. So I think that's the prism at which to look at these things. I think the GINA legislation that was passed a few years ago took a lot of the bad stuff off the table by not allowing at least health insurers to discriminate based on genetic information that's public.
The single thing that concerns them the most is who will have access to that information. And I think we experience that at Claritas also, is ensuring that we have a HIPAA-compliant standard process by which data privacy is ensured for individuals, and the methodology by which we deliver data back to patients.